What's up everyone, welcome back to another video. I'm Yusuf, and in today's video we're going to be going through section D, problem 3 of the SolidWorks mock exam. So if you don't yet have yourself a copy of this, you can get one from the link in the description. So heading straight into it, we can see we have some sort of mounted hook with two slots and a weirdly shaped protrusion at some angle across the plate. So let's dive straight in. So we have a base plate, and we're given dimensions for the base plate. We have a thickness, and we aren't given an angle that this is sitting at. We are given some hints to the angle from the rest of the geometry. So let's start with our base plate. We have a base rectangle of 62 by 88, and we have two slots, one on either side. So I'm going to mirror the slots, do one on the side, and take it from there. So the dimension of the slot is 6 mils diameter, which means 3 either side, and the distance from here to the bottom would be 10.5, and this is centered with the plate, so we can make that horizontal. That dimension is 41, so we can do away with this and keep the dimension that's given as 41. So if ever there's a change to it, we can make that quite easily. Then the distance between this inside edge of the slot to the outside edge of the plate is given as 8 millimeters. Then we can mirror entities, select our slot. We're going to be mirroring about the center line. Okay, cool. So the question does mention that the part can be built using only 3 features. I don't really follow that at all. It became more of a hindrance when you chase the least number of features in practical settings. It's always best to go for what makes the model easiest to modify later on. So keeping a clean feature tree is important, but being able to modify your model later on is importanter. So do that instead. So that's it for this section. We can now extrude. We have a thickness of 7 millimeters. Then we have the hook segment, which runs across from the center of this end of the right slot to this end of the left slot. So we need to firstly create an axis at each end that we want to use. So we're going to go to reference geometry again. Okay, now we can create our plane. Once we have our plane, we can start doing our sketches. So we can start over here. We can head up some distance. Then our height here, and then back to our original starting point. So we are given an angle of 36. We're given a height here of 20. Distance across here as 4 millimeters. Now, the one issue that I did pick up, wait, before I get to that, we have a distance here of 20 millimeters as well. Okay, now the one issue I did pick up in the question is that the size of this hole is not given, and neither is the distance from the end of the hook to the corner or any other point that we can use to reference off. So how I worked it out was the diameter across this here is 14 millimeters. So from the end to the center of the circle, which appears to be concentric, is going to be 7. Then 7 millimeters plus another 8, which is given here, will give you your distance when it comes to the sketch. So from here to there, we have a distance of 7 millimeters plus 8 millimeters, giving us 15 millimeters. So we can go ahead and extrude that. So when we extrude this, we are going to be using the mid-plane extrusion to a thickness of 14 millimeters. We have 2 rounds on either side. And because the diameter is 14, the fillets are going to be 7 each. Then we have a hole in the middle again, which is not given in our PDF. The size of the hole is not given, so I assumed it to be 8 millimeters. And that seems to be what works best. So heading back, I'm going to stick with 8 millimeters. And we can go ahead and cut extrude that. Up to next, add in our chamfers. Our chamfers are going to be 6 millimeters each. Last, okay. And then just for neatness, I'm going to hide those. Okay, so that's our geometry done. The next issue I picked up is if you go to edit material and you go to alloy steel, which is what's listed in the question, you'll see that the mass density given is 7,700 kilograms per meter cubed. But in the question, it's listed as 7,300 kilograms per meter cubed. This value given in the question is incorrect. It should be the same as what SolidWorks has listed as 7,700. So I'm going to apply that, and we can go to evaluate mass properties. We get a mass of 310.44 grams. So heading back, our answer is 310.44 grams. Well done. If you got the same answer, congratulations. If you didn't, let me know in the comments where you got stuck and how you managed to solve it. And if you like these videos, please subscribe, like, and leave me a comment. Let me know what you like about the videos. Let me know what I can do better. Let me know what I'm not doing well enough or what you'd like to see on the channel. I love to hear your feedback, and I will do my best to respond to every comment that I get. So hopefully you guys enjoyed this video, and I will see you in the next one.